Yes, hi. So I will be leading you through some of the student hat experience. So at this point, as we're starting to shift here, imagine yourself as your inner like sophomore chemistry student. So as we ask you to notice and wonder and engage and answer questions, put yourself in your student's seat. So Sarah, if you could go to the next slide. So in our last unit, we figured out a lot about how human activity is causing changes to the particle level that is affecting all of Earth's systems, including people. In this unit, we're going to use some of those same strategies to figure out what's happening with a new phenomenon. So this unit is probably a phenomenon that all of you have seen at some point in your lives, but I have a video here that maybe if you haven't experienced it, we can watch. So we have an example so everybody can engage in our conversation. So Sarah, if you'd go ahead and play the video, and then as you are watching the video, think about what's happening and where's the lightning going from and to. Okay, so if you want to share in the chat, what did you notice? What's happening in this video? Okay, so Elizabeth says it seems random. There doesn't seem to be a pattern to the lightning strikes. Okay, so we're seeing kind of some directions coming up here. So going from lower points to higher points and also from higher to lower. Sometimes it's going horizontally. There's a lot of lightning. It's going from cloud to cloud, cloud to ground, ground to cloud. Yeah, it's happening very fast. So lots of different noticings about it. There's like a branch. It looks like it's branching out a little bit. Jagged patterns. So I'm guessing that means like it's not a straight line. There's like it's not static. So let's think about this. I saw that it's like happening really, really, really fast. So let's look at this at a different time scale. Let's like slow it down a little bit to maybe help us see if there are any patterns to the lightning. So Sarah, if you could go ahead and go to our next slide. So we're going to look at some videos that have slowed down the lightning. And so I want you to set up a notice and wonder chart, or if you look on the Jamboard, there's the very first table of the Jamboard to where you could record some of your notice and wonderings as we look at these slow motion videos. All right, so if you want to go ahead, I don't know if it'll, maybe there it goes. All right. Let you watch this one a couple of times. So again, just notice and wonder what's happening in this slow motion video. Okay. We'll watch it one more time. I think it's going to start again here. Okay, so I'm seeing a lot of noticings come up in our Jamboard here. Looks like Fireworks. I see a couple of folks have added that it's branching out like tree branches, starting from one spot and branching out. We're seeing from more directions from the sky to the ground. And then some of our wonderings we have, like, why is it bright? Why is it splitting apart? Why is the branching happening? Why doesn't it just stay on the ground? So lots of great wonderings here. So I think let's go ahead to our next slide here. So we all have like different backgrounds and different stories that we've heard about with lightning. I know growing up what my great grandparents would tell me about lightning to kind of help me feel a little bit better, because sometimes as a little kid those were really scary. So we're going to respond to this in a chat storm. So you're going to choose one of these three questions. What do you know about lightning? What stories, family history, and mythology have you heard about lightning? Or how do these stories help us make sense of lightning in its role in the world around us? So with the chat storm, I'm going to give you about 30 seconds or so to type in your response, but don't hit enter yet. We're going to wait. So I'm going to give you about 30 seconds or so. No worries, Elizabeth. 30 seconds or so to type in your response, and then I will tell you when to hit enter. Okay, lots of great things. So let's see. I see a lot of people, Angels Bowling for the thunder. I hear it's coming with thunder and on stormy days. You can count the seconds between when you see the light and hear the thunder to figure out how far away it is. A lot of people talking about electricity and changes in electricity. Grandpa saying it's good for plants because it adds nitrogen to the soil. Places where it's safe and unsafe, like being in a car. I'll never strike the same place twice. So we have a lot of different ideas about lightning. So we're going to hear and take some time to look at some different stories about lightning. So Sarah, if you could go to the next one. So for this slide, we're in our essence of time, I'll just kind of talk you through a little bit of these. So students would be broken up into 4 different groups. 2 of the groups, the Navajo and the Oyo, would be watching, I think, watching videos about lightning, and then there's a reading about mythology, and then also a reading about inventors. So students would have a chance to kind of like go out, hear some different perspectives, different ways of knowing about lightning and what we have thought historically, and have some time to share and engage in some additional stories before we go to our next learning step. So Sarah, if you could go ahead to our next slide. So we're going to get into some data analysis here in Student Hat and let you experience this. So just if you have a sheet of paper available to kind of stop and jot and record your responses looking at these 3 different graphs. So we have the graph with the green, the red, and the blue. So I'll give you some time here. What do each of the graphs show? What are the patterns that you're noticing across the graphs? And what are some questions that you might have? And at the moment, just go ahead and record those on a sheet of paper. Okay, give you about 20 more seconds here. So what about that first question? What did we see? What is this data showing us in these three different graphs? I think you can put it in the chat. Okay, so lightning versus the time of the year or the season. Okay. Were there any patterns that stood out to you looking at these three different graphs? Okay, so I'm seeing it's more prevalent during the summer. So we're seeing a certain time of year, summer has more lightning than winter. Okay. And then are there any questions that you might have about the data? Okay, so how are they collecting it? That's a good question. Okay, why is it happening more often when it's hotter? Where are we collecting it? Mhm. Okay. How does this compare to other places in the United States? It says who the data is coming from, who's the agency, how it went down in the fall, but up again in December and then back down again. So we're seeing a lot of different wonderings here, how recounting it. So I noticed several of you asked some questions about like, where is the data coming from? So let's look at a map of the United States and see like where, if there are portions of the United States that maybe receive more lightning than others. So Sarah, if you want to go ahead to the next slide. Okay, so I know we're probably from all over the United States. So go ahead and find your state, think about the colors, and what do you notice about that? And so when we look at the different colors, that's the flashes per square kilometer per year. So it's measuring like this density or how often is the lightning occurring in specific places. So in your notebook where you've been jotting down the other data, I want you to go ahead and you can add to that of what are some of the things that you're noticing as you're looking at this data, and what are some of the things that you are wondering about. So I'm going to give you probably about 30 seconds or so. I know that's a short amount of time, but I want to make sure we have time to talk about it. So about 30 seconds to look at the data and jot down anything that seems interesting for you. Okay, so about 5 more seconds to wrap up your thoughts. So what were some of the things that stuck out to you looking at this data? Okay, so the areas with the most lightning had high heat and humidity. Areas with fewer flashes have low humidity. More strikes in states that are flatter, and it was between our mountain ranges. Okay, in the center is the most frequent lightning occurring. Okay. What about any wonderings that you may have had looking at this new set of data? Okay, so does elevation matter? The least amount is on the West Coast. Why don't they get lightning there? How they're collecting it? Why does it get lower below Florida? Okay. Okay, what's happening in Arizona and New Mexico? What is there? Yeah, it looks to see like there's some little like spots of like a lot of lightning in that area in certain parts. Yeah. So let's like look at an even larger place scale and look at some lightning strikes across the world. So if Sarah could go to our next set of data. So we've seen and we've heard some ideas about lightning in the United States, but what about the rest of the world? What's happening here? So this data was collected by different satellite sensors from 1995 to 2020. And I want you to notice, like, as you're looking, the darker the color is on the scale, the less lightning flashes were being picked up by the satellites. So those bright yellow colors on there are getting a lot of flashes being picked up by the satellites. So I'll give you another like 30 seconds or so to again, what are some things that you're noticing and patterns that you might see and some questions that you have. Okay, about 7 more seconds or so. So what were some noticings that you had looking at this worldwide data? Okay, so several of you are pointing out that there seems to be a lot more lightning happening at the equator versus at the poles. We have a question, does the lightning not like the cold? Because we're noticing it's not in the colder areas. There really isn't any lightning in the desert areas. Um, okay, so we're starting to get an idea of where lightning is and when it's happening most often during the year. So we're going to spend some time looking at other impacts, like what happens after the lightning strikes, now that we know kind of when and where it tends to happen more often. So we're going to look at some data. We do spend some time talking about this data. To help support students' social and emotional learning, especially thinking of, experiences that students may have had that were not so great with lightning data. So this next set of data, there is some discussion and some framing to support students around that, to support them emotionally, because we are looking at fatality data. So, oops, I have a friend. So we're going to silently look at this data. And again, you can add some noticing and wonderings to it. We're not going to take a lot of time to discuss this data, but just kind of you can put in the chat, like, what are some of the things that you tend to notice comparing this data to some of the data that we saw before of the United States? Okay, so what are some of the noticings that you have looking at this data? Okay, so seems to be a higher death rate in the southern portions. California has more fatalities than they would expect given the lower amount of strikes. Oh, does a hurricane impact the data results? More populated areas tend to have higher. Okay. Okay, is there a connection between tornado alley and lightning? So we're getting a lot of really good questions coming out here. So let's kind of try to pull all of these things together. Maybe it is worse in the mountains. And think about and notice some patterns across the way. So Sarah, if you could go to the next slide. So I've seen a lot of things coming up in the chat around some wonderings that you might have and kind of making and matching some patterns together, kind of pointing out here, like, is there a connection between tornado alley and lightning? Is there a connection between hurricanes? Noticing about elevation came up again, location. So if you want to go to, I think it's our second frame on the Jamboard. I can never remember. It's called a frame. What are some things that seem to influence where or when lightning occurs from some of our ideas that we've put out there? Okay, so distance from the equator. Oh, humidity. Can whoever shared that, can you share like what is humidity when you say that? Like maybe not everybody knows what that means. So I'm seeing moisture, how hot or cold it is. So if you're closer to the equator, okay, if it's in a mountainous region versus being flat, okay. So the type of weather to make the clouds, right? So it's starting to see like some ideas and some patterns that we have in here that seems to be moisture is a thing, maybe elevation is a thing, and then like global location, is it more towards the equator? So we're starting to kind of come up with some really great ideas and thinking about patterns. So let's kind of think about developing some initial models. So this is just our second unit, and just kind of thinking about it, models are always trying to answer a question or using them to explain a phenomena. And so for this one, just kind of as an example, we're going to think about like, how would you create a model to explain to somebody, how do you move a soccer ball with your foot? And so we would consider the components. What are the different pieces? How are those different pieces or components interacting together? And then what are the underlying mechanisms that maybe we can't see that cause the movement and lead to the movement? And so as a class, we would work through this example together just to remind ourselves of modeling since we're in our second unit of the year. So Sarah, if you want to go to the next slide. So together, we would be working with a partner to brainstorm the different components that we would include in our model to try and answer the question, what causes lightning to strike at a particular place or a location and time? So this could be time of year. And so you would brainstorm these components with a partner. Since that's hard for us to do virtually, just take a moment to think about those on your own. And then I'll give you like, I don't know, 3 minutes, 2 minutes or so to quickly jot down an initial model. Okay, so we'll do about 2 minutes to think about the components and then jot down an initial model to answer a question again. What causes lightning to strike at a particular place and time? Okay, about 20 seconds left or so to kind of wrap up your initial model thoughts. Okay. So I'm going to have you just hang on to those initial models for a second. Let's have a real quick chat storm conversation. So Sarah, if you want to move to the next slide. So again, we're going to do this as a chat storm, and we're going to have you answer all three of the questions. So again, I'll give you about 30 seconds to type them in. And then after that 30 seconds, I'll tell you when to push enter. So to help us out, make sure to put 1, 2, and 3 with your answers. So let's just kind of think about this. Some of you have talked about like lightning is electricity and there's changes. So is lightning energy or matter? What's the evidence do you have to support either one of your ideas? And how would answering these two questions help us figure out what is causing our lightning? Okay. Okay, so go ahead and hit enter. Okay, so we're seeing light is a form of energy. Going to help us think about the energy here. It's light and sound. Okay. So we have a lot of ideas here around thinking around lightning as a form of energy and differences between energy and matter and connecting those together. So Sarah, if you want to go ahead to the next slide. So at this point, kind of after we've thought about that thinking, we would have students go back and revisit their initial models to show where the particle level changes are happening within the system, and then also layering in and adding on energy transfer models to show where energy transfers are occurring within the lightning system. So we want to go ahead to the next slide. So then we, after giving students that revision time, we would work in a scientist circle to develop our initial classroom consensus model. And the next slide shows an example of that model. And so here you can see that they've kind of layered on after drawing the initial model, some ideas about matter in the red text, and then energy in the blue text. And I do want to point out in the energy transfer diagram boxes at the bottom, that type of notation had been previously developed in the first unit. So that is something students had some relationships with. So you can start to see here some of the interactions that students are showing. Some of the questions that we're unsure about is what is causing the lightning to move from place to place, a matter thing or an energy transfer idea. And so last slide, we would do our related phenomena. So I don't know if we have separate Jamboards because we are a bit of a smaller group, but go ahead and add in on the Jamboard some ideas of related phenomena, where and when have you experienced this, how do people protect themselves from lightning, and then some questions and ideas for investigation.
And that's across frames 3 through 5. So you can just keep clicking over.
Thank you, Dan. So some related phenomena that looks like it's coming up here for several people is static electricity, protecting ourselves from staying inside, welding. Lightning strikes at the highest point. Sparking outlets, staying away from water. Okay, and then if you haven't yet, I know I'm rushing you all. I want to make sure Dan has plenty of time to talk you through the rest of this amazing unit. Go ahead to, let's see, the driving question board if you want to go to the next frame. So any additional questions that you haven't shared in the chat, go ahead and post those there. Okay, is water vapor required? And then we would have some ideas for initial questions. So I think I know I'm doing a terrible job of honoring all of your amazing questions and ideas, but I do want to make sure that we give Dan time to talk through what happens next. So Sarah, if you want to go ahead and go back to the slides and we'll hand it back off to Dan to talk us through the rest of the unit.